Thank you for joining us for another MOLYKOTE webinar. This webinar is going to be on lubricant additive packages for the MOLYKOTE product line. We have Cassia Hegel that will be running through this webinar for us. Cassia, why don't you get started?
We could start by doing a quick overview on MOLYKOTE. And just to begin, information that we've shared before, MOLYKOTE has a pretty comprehensive product range which encompasses multiple chemistry sets, which are often selected for very specific application requirements with specific performance parameters in mind. And oftentimes we'll select products based upon compatibility between an application and a specific chemistry set. For example, a commodity non-synthetic base oil like mineral oil will likely not match the high performance capabilities of a synthetic base oil like a PAG or a diester, especially in regards to performance requirements such as oil bleed, wide temperature ranges, and load carrying capabilities. Next, we could take a look at MOLYKOTE as a whole. And the MOLYKOTE portfolio encompasses multiple product families and technologies encompassing greases, pastes, oils, compounds, dispersions, and anti-friction coatings. And when identifying a particular lubricant for a specific application, we use the LETS acronym, which stands for Load, Environment, Temperature, and Speed. And depending on specific application parameters, the overall function of the lubricant in application will vary, and the lubricant may function to either separate surfaces, reduce wear and friction, manage contamination, protect against corrosion, provide electrical and thermal management, or transmit power. Additionally, when we consider lubricant selection, it's important to consider the friction dynamics. And to understand friction dynamics, we study tribology. And tribology is the study of friction and wear between moving interfaces. And this concept can be broken down into three separate friction regimes, including boundary friction, mixed friction, and hydrodynamic friction. So boundary friction would include slow-moving, high-load applications. And an example of an application involving boundary friction is press fitting. And for applications involving boundary friction, we would often lean towards the selection of either a paste or an anti-friction coating, which are lubricants in which the solid lubricant is acting as the primary lubricating agent. In those such cases, it's important to consider the capabilities of the solid lubricant in the formulation when we're selecting a chemistry for that application. In contrast, you could also have a hydrodynamic friction regime. In contrast, this sort of regime encompasses fast-moving, low-load applications. And for applications involving hydrodynamic friction, we typically would lean towards a grease or a fluid. And in those such product families, as a grease or a fluid, it's the base oil in the formulation that's acting as the primary lubricating agent. You could also have a mixed friction regime, which is a mix of both boundary friction and hydrodynamic friction regimes. And in those such cases, you could tend to lean either towards a grease with solids, so something with a lot of high tack to it, which we sometimes refer to as grease pastes within the portfolio, or a dispersion, which are usually solid polymeric additives suspended in high purity solvents to form almost like a semi-dry type film. Also within the portfolio, a lubricant can be selected for enhanced functions beyond just friction and wear. And depending on the application needs, a lubricant can be selected for either thermal or electrical management, corrosion mitigation, oxidative stability, noise dampening or noise vibration, and harshness control, or for green labeling. So next we could take a look at lubricant additives, which are incorporated into formulations. So additives are incorporated into specialty lubricant formulations when the base oil itself doesn't provide all the required properties needed in a given application. For example, if an application requires fretting resistance, it's unlikely that a base oil alone would provide all the functional benefits needed in that application. So additives are incorporated into the formulation in order to meet performance criteria. And since lubricants are formulated to fit a diverse range of applications, different lubricant technologies, like different types of product families, will often use different combinations of base oils and additives. And since base oils alone rarely satisfy all the required properties of a lubricant, additives can be used to amplify the favorable properties of the base oil and potentially mitigate some of the unfavorable properties of a base oil. And overall, additives can potentially interact with one another and have multifunctional properties. And any given additive package is often a very unique formulation blend that overall produces a very complex chemistry with both positive and negative interactions. So let's take a look at how additives are incorporated into our different MOLYKOTE technologies, starting with the grease. So within the grease family of lubricants, additives typically comprise 10% of the overall composition, and the types of additives that are formulated into any given grease will really depend upon the anticipated application. For example, you could see the addition of oxidation inhibitors, extreme pressure additives, rust and corrosion inhibitors, or viscosity index improvers. So additives that are either improve the overall performance of the lubricant itself or somehow enhance or modify the actual physical properties of the lubricant. So now we could take a look at paste formulations. So in a paste, which is primarily formulated by dispersing solid lubricants in a carrier oil, additives take up 1 to 5% of the overall formulation, so a bit less than what you would see in like a grease formulation. And the amount of solid lubricant in the formulation also varies. So you could have a very high percentage of solid lubricants in the oil and form kind of a very tacky grease-like paste. And overall, the choice of the additives within the formulation are very much application dependent. So again, you could select additives for corrosion protection, to increase the tackiness of a formula, or even to thicken the material overall. So now we could look at additives in compound technologies. So in a compound, there's typically less additives dedicated to the overall formulation than you would see in a grease and a paste. So with additives typically taking up between 0 to 3% of the overall formulation, so a lot less overall. And many additives can have more than one objective. So they offer multifunctional benefits, minimizing the need for lots of different additives in a formulation. Sometimes the job of one lubricant additive will minimize the need for multiple additives to be incorporated into a formulation. And ultimately, it's important to consider the fact that that additives can interact with each other. So they could either undergo synergism, where the total effect is greater than the sum of the effects independently, or antagonism, where the observed total effects is less than the sum of each additive individually. For example, that kind of antagonism can occur when you combine anti-wear and corrosion inhibitors with friction modifiers. One additive can ultimately mitigate the effects of another additive. So when you combine those three additives together, you could minimize the effect of the friction modifier, sometimes overall mitigate the effect of the corrosion inhibitors. So it's really important to consider the combination of additives that you're adding to the formulation. And overall, just the proper balance of additives is very critical just for minimizing the harmful effects of the antagonism with the additives. So lastly, we could take a look at our fluids and oils. And in these formulations, you could have either chemically active additives, and these would include anti-wear, extreme pressure additives, antioxidant additives, or rust and corrosion inhibitors. You could also consider the addition of chemically inactive additives, and these are primarily incorporated into the overall formulation just to influence the physical characteristics of the material. And these types of additives would include foam inhibitors, pour points depressants, and viscosity index improvers. So next, we'll take a look at the different additives and their uses within a formulation. So we'll talk about additives in greater detail here. So we can distinguish additives by two primary categories, either bulk additives and surface additives. And bulk additives affect the rheological and interfacial and chemical properties of the lubricant, whereas the surface additives are just active at metal surfaces. Then the specific additive chosen for the formulation ultimately will depend on the overall application. So, for example, the need for antioxidant additives may occur when you have a system that's exposed to high levels of heat, oxygen, or metal contamination. And in that case, when you have a grease or a lubricant in that kind of system, it will start to undergo oxidation. The lubricant itself will begin to oxidize. And when that happens, the base oil itself will not be able to prevent against the effects of oil oxidation. So ultimately, what will happen is that oxidation will produce polymers that overall increase the viscosity of the grease or of the lubricant, and eventually accelerate the wear and lead to varnish of that surface that you're applying the lubricant to. Also, oxidation, it could potentially form an oil-insoluble sludge that would lead to eventually plugging of oil lines and filters, leading to oil starvation in machinery, and also causing adherence to the metal surface, which would ultimately accelerate wear. So antioxidant additives would ultimately mitigate these effects of oxidation and also the formation of any of these like deposits like that sludge. Also, you can incorporate anti-wear additives into a formulation. And anti-wear additives are different in that they are most effective at moderate loads and temperatures. So again, it's important to consider the application requirements when considering the additive that is being incorporated to a formulation. And in the case of an application requiring anti-wear additives, the addition of the anti-wear additives ultimately will allow for the formation of very durable films, mainly sulfate, sulfide, and phosphates of zinc, iron, or other cation species. And these films will ultimately continue to be replenished for as long as the additive is present in the formulation. And you could see the use of these extreme pressure additives or these anti-wear additives in these such applications where you have moderate load and temperature. In contrast, you could use extreme pressure additives where you have essentially very highly loaded conditions in order to prevent welding of parts. So typically you see extreme pressure additives as either sulfur-based or molybdenum-based, and typically these extreme pressure additives contain sulfur compounds, molybdenum derivatives, and chlorine compounds. And the primary difference between the different types of extreme pressure additives is essentially the activation temperature. So again, it's critical to consider your environment of the application when considering the type of additive that's being used. So also you can consider the use of corrosion and rust inhibitors when you have a lubricant formulation. And essentially, these additives react with the contacting metal and form these protective coatings on their surfaces in order to protect these materials from the harmful effects of water, polar impurities, and oxygen. And just to speak of corrosion a bit more, corrosion in itself is an electrochemical reaction between the metal surface functioning as an anode and the interface between the metal surface and the lubricant as the cathode. And in such a case, a metal surface in contact with oxygen and water will react to release metal into the oil. And the corrosion inhibitors eventually will prevent this process by essentially chemically insulating the metallic anode from the cathode. Additionally, you may see rust inhibitors in a formulation, which are very similar to corrosion inhibitors. And the main difference between a rust inhibitor and a corrosion inhibitor is where they function. The corrosion inhibitors typically protect copper surfaces, and rust inhibitors usually protect iron surfaces. And chemically, both additive types are very similar, and they both have these polar head groups that attach to the metal surfaces and hydrocarbon tails that form a film to protect the metal surfaces against the electrochemical attack. And in a given application, you could also see the need for a friction modifier additive. in the Striebeck curve that we looked at a few slides ago, you can kind of see how friction reduction takes place via lubricant. So in a given tribological system, according to the Striebeck curve, you can either have boundary or mixed friction regimes where the lubrication conditions could be detrimental to the machinery. So if using a grease or a lubricant without additives, the contact could eventually lead to significant system wear and eventually premature field failure. So the incorporation of a friction modifier additive could ultimately help you significantly reduce the coefficient of friction in these regimes and eventually delay field failure. So next we could take a look at some specific MOLYKOTE additive packages for enhanced wear resistance, metal galling, and corrosion resistance. So we'll start by taking a look at the different MOLYKOTE grades that could be used for specific application performances. So if you have an application requiring anti-wear additives, MOLYKOTE BR2 Plus high performance grease will incorporate anti-wear additives that lend the formulation great load carrying capabilities, extended lubricant operation life, emergency running in properties, and great wear and rutting protection. So this particular grease would probably be best suited towards applications like rolling element bearings, bushings, and power screw drives. In contrast, if you have an application that requires corrosion and rust resistance, MOLYKOTE 55 O-ring grease is probably a good standard product to consider. It's a good standard O-ring lubrication grease that also offers excellent resistance to oxidation, robust thermal stability, and good corrosion protection. Additionally, if you have an application in an extreme pressure sort of condition, MOLYKOTE G4700 extreme pressure synthetic grease offers EP additives, extreme pressure additives that provide higher load carrying capabilities and greater wear resistance, as well as longer service life compared to a lot of other conventional petroleum-based lubricants. So when we try to look at specific applications and specific trying to cater a lubricant towards a specific application, corrosion's a pretty common issue that we tend to look at in application. So it's one that we could consider for, in an example, to select correct additives for a given application. So corrosion affects a lot of different materials, particularly metals, and this issue it's pretty common. And one way we could kind of mitigate corrosion is through the selection of the appropriate additives in a given formulation. And one of the best ways to prevent corrosion is through proper lubrication. And that can be accomplished through a number of ways. One is that the lubricant essentially provides barrier formation. So it provides a protective film on the surface of a metal, and it'll act as a barrier in order to slow down the exposure to moisture and corrosive agents. Additionally, the lubricant will act to reduce friction. And by reducing friction between moving parts, you're essentially minimizing wear and tear. So it's another way to sort of mitigate the occurrence of corrosion. Additionally, the lubricant can also help with moisture displacement. There's certain lubricants that have properties that allow them to displace moisture from the metal surfaces, again, reducing the likelihood of corrosion. Chemical protection is another thing that lubricants will provide in a corrosion mitigation type application, because a lot of lubricants contain additives that provide additional protection against corrosion. And what these additives really do is they neutralize the acidic contaminants, or they provide a sacrificial layer that corrodes preferentially, ultimately protecting the surface that you're lubricating. So the base metal, really. Lubricating a part for the purpose of mitigating corrosion, you're also essentially providing long-term maintenance. And ultimately, by selecting and applying the proper lubricant, you're able to extend the lifespan of your machinery by preventing rust and deterioration. So overall, it's pretty critical to select the right lubricant in an application where you're looking to essentially mitigate corrosion, because not all lubricants will offer the same level of corrosion protection. So when selecting a lubricant for corrosion mitigation, it's important to consider the additives that you're incorporating into the formulation in order to complete this task. So now we could kind of look at sort of general guidance for selecting materials for corrosion resistance. As we mentioned before, a good standard product for corrosion resistance in many applications, particularly for sealing applications, is MOLYKOTE 55 O-ring grease. And then based upon sort of additional enhanced performance needs, you could also select more tailored products from the portfolio. For example, if you have a application where you're requiring a lot of like high tack and adhesion, P1042 adhesive grease paste is probably a good option. Just given the tackiness of the grease, you'll often see this type of grease used for applications like vertically mounted gears, particularly in highly exposed environments where you're exposed to moisture and other contaminants that could potentially facilitate corrosion. Also, if you need chemical resistance to a variety of solvents, MOLYKOTE HP300 grease, it's a fully fluorinated grease that has wide compatibility to multiple substrates. And then additionally, for long-term lubrication, MOLYKOTE BR2 Plus high performance grease is a mineral oil-based grease that has great running-in properties and will also provide corrosion protection over time. So next we could look at wear resistance and additive packages specifically for wear resistance. So wear resistance additives and lubricants are essential for enhancing the performance and the durability of lubricating oils and greases. And these additives essentially help reduce friction and wear of moving surfaces by improving the longevity of machinery and equipment. And additives that help achieve this effect would include molybdenum disulfide, which is a solid lubricant as well that can be used as an additive in oils and greases. And it provides excellent load-bearing capabilities and reduces friction and wear, especially in extreme pressure applications as well. Additionally, you may see graphite, like molybdenum disulfide, used as a solid lubricant in order to enhance wear resistance in an application. And the graphite kind of functions similarly in that it creates a lubricating layer that ultimately reduces the coefficient of friction between surfaces. Lastly, we could have white solids that are used as additives that also enhance wear resistance by essentially offering a thicker lubricating film that could withstand much higher loads. So really, MOLYKOTE offers a host of products, as you can see from our solutions that are listed, that incorporate either some or all of these additives in order to really increase wear resistance in a given application. And then lastly, metal galling. So metal galling, sometimes referred to as just galling, it's a form of wear that's caused by adhesion of two sliding metal surfaces. And metal galling really occurs when there's a transfer of material between two surfaces, which essentially just leads to significant damage and failure of components. So by employing proper lubrication, you could decrease the occurrence of galling by reducing friction. And proper lubrication really is essential in managing metal galling because the proper lubrication essentially will form films that reduce friction, control heat, and protect surfaces from direct contact and the wear effects. So additionally, some additives can form protective barriers or react chemically with the surfaces in order to enhance those protections during boundary lubrication conditions. And then within the portfolio, additive packages, particularly with white solids, which include metal oxides, hydroxides, phosphates, and sulfides, can really help protect against metal galling. And white solids have even been known to outperform molybdenum disulfide in terms of endurance. So next we'll take a look at a specific application. So in this particular application in the oil and gas market, we have a customer who's a global leader in oil drilling technologies, and the application they have is essentially to improve the reliability of rotary steerable drilling equipment by reducing thread failure. So the solution here would be some sort of anti-seed anti-seize thread paste. And the challenge in this application is to prevent cold welling, galling, and then the failure of these stainless steel threaded connections, which are tightened to very high torque levels. Given the specific materials that are used in the threads themselves, it's important to consider using a lubricant that is ultra pure and metal free in order to be compatible with the substrate used in this application. So the lubricant that's used in this particular application here is the P37, which is a ultra pure anti-seize paste. And ultimately, this paste was able to work in this application because of its high purity and the fact that it's metal-free, which protects against cold welding, galling, and embrittlement, and also allowing the non-destructive disassembly of these threaded components. So now we could just look at some MOLYKOTE capabilities. So MOLYKOTE offers a wide range of in-house lab capabilities in order to really determine if a lubricant selected for a particular application is truly compatible for that application. So we have tools and technologies to evaluate the material properties, the application, the performance of a material in that application as well. We also have a range of advanced capabilities, including cyclical corrosion, electrical characterization, polymer elastomer compatibility, as well as noise, vibration, and haptics testing as well. Overall, MOLYKOTE delivers a wide range of product solutions ranging from different technologies, including greases, anti-friction coatings, dispersions, in order to suit a variety of different application needs. Thank you. That's all I have.